Hi everybody, and welcome back to our data structures and algorithm series. In this video, we are learning about queues. So first, what are queues? A queue, like a stack, is a restricted access linear data structure. Unlike a stack, both ends are involved. When items are added to the queue, they're added to the end of the queue, and when items are removed, they're removed from the front of the queue. An item added to the queue, therefore, has to migrate from the rear of the queue to the front of the queue before it's removed. And items are removed in the order they are added. So for this reason, queues are known as a first in, first out structure, or FIFO. So queues can be implemented by utilizing an array. As items are removed from the queue, spaces open up in the front of the array, which should not be wasted. So items are added at the end of the queue, which is at the beginning of the array. And this treats the array as though it was circular. And now that is a weird concept to think about, but what we're going to do is first I will show you the operations of a queue, and then we're going to draw out how we would implement the queue as an array. After seeing it drawn out, we will then implement a queue using an array. So first, let's discuss the functions that we will be implementing in our queue. So one of the functions will be clear. This is pretty self-explanatory. This clears the queue, so it just empties the queue. Another function that we will use is empty. And this checks whether or not the queue is empty or not. Now, the next function that we will write is enqueue. And this adds a data element to the end of our queue. The other function is dequeue. Dequeue removes the element in the front of the queue from the queue. And first, EL returns the first element in the queue, or the element that's in the front of the queue. So it's just going to return what it is. It does not remove it from the queue. This is similar to our peek operator that we did when we implemented a stack. So let's draw this out. Let's say that we have a queue that has 5 elements in it. So that means that we would make an array that has 5 elements. When using a queue, we have to keep track of the first element in our queue and the last element of the queue. So I'm going to write here first, and first is equal to -1. And last will also be equal to -1. And that's because our queue is empty. So at this point, since our queue is empty, our first and last index point to -1, which means that there's nothing in the queue. So let's say we enqueue 1. When 1 is added to the queue, our first and last now get updated to be 0. Now let's say that we enqueue 2. When we enqueue 2, our first stays 0, but our last will now be updated to 1. Now, if we dequeue from our queue, we look at what is the first element in our queue and we remove it. The first element in our queue is at 0. So if we call dequeue, our first element, 1, will be removed from the queue. So if we draw that out, only 2 is in our queue, and our first gets updated to become 1. So now our first and last are equal to 1, but our queue is not empty, right? So now let's continue adding to our queue. So we'll add 3, 4, and 5. So when we add 3, our last becomes 2. When we add 4, our last becomes 3. When we add 5, our last becomes 4. So now we want to add 6 to our queue. Our queue is not full. And that is another check that we have to do when we enqueue or add to our queue. We have to check if our queue is full, because otherwise we can't add an item to our queue. So in this case, our queue is not full because our first is 1 and our last is 4. Our first is here, our last is here. When we add 6, we look at our last, we see that our first is 1, and because our first is 1 and our last is 4, there is an open space at 0. So we add 6. By adding 6, we update our last to become 0 again. So now our queue is full. And we know that our queue is full in 2 cases. We know that if our first equal to 0 and our last is equal to basically the size of our array minus 1, but in this case 4, or if our first equals last plus 1. This means our queue is full and we cannot add any more items to our queue. So hopefully from the example we did here, you can see what I mean, that when implementing your queue, you think of your array as a circle. Our array can be drawn kind of like a donut. And within this donut, we are adding items to our queue. So in the case that if this was our first, we have 2, 3, and so on. And when they get removed, we have the space. So here's our first and our last. But we dequeue, so we remove 2, but we still have the space to keep going. And that's why here it can just be warped a little to become a circle. So now that you've seen how a queue works drawn out, let's take this and implement a queue programmatically. So I've created a new folder here called queues. And in this folder, I'm going to add a new class file. I'm going to add something called queue array. Now we're going to implement a queue using an array, just like the example that we drew out earlier. So I'm going to include our IO stream because we're going to outprint. And I'm going to also use our namespace, our standard namespace. For simplicity's sake, I am going to define the class and then also write the main function in this file. So the name of our class will be queue, and this will be a template class, just like we implemented with our stacks and our linked lists. So I'm going to define it as a template class T, and we're also going to define the size of our queue in our template, int size. And if we do not pass a size, it will default to 5. So our class will be queue. We'll add our semicolon now. Now, if you remember, we needed to keep track of the first element in our queue as well as the last element in our queue. So we're going to have some private variables, which will hold int first and last. So this will be our markers for the first and last items in our queue, and it's corresponding to the index. We also need to initiate how our queue is stored, and that was going to be an array. So the array would be of the type T, and we'll call this storage, and the size of the array is the size that gets passed in. And if the size is not passed in, then it will default to 5. Now we have our public attributes. So first, we want to define the constructor for our queue. In the case for our queue, when we are initializing it, we already have our storage set up. We just need to set our first and last index. When we're initializing our queue, we're going to make our first and last be equal to -1. Because the queue is initially empty, we can make it -1, and now we know that the queue is empty. So we're going to set first equal to last, which is equal to -1. Now, if you remember, the other methods that we had to define are clear, which cleared the queue. So that would be a void method called clear. Then we have the method isEmpty, which would return a bool because it's telling us whether or not the queue is empty. Then we have enqueue, which adds a data element to our queue. So that would be TEL. Then we have dequeue, which removes the first element in our queue. So that would return type T, dequeue. And finally, we have first element, which just gives us back the first element in our queue, but does not remove it. So now let's define our clear method. And in this scenario, we're not going to worry about deallocating memory or any of those things. We're just going to treat clear as the simplest implementation that we can do. And in this case, when we clear our queue, we are making our queue empty. So it's like the queue has been reinitialized again. We can take our code from when we constructed our queue, and that's what we would use for clear. Now, isEmpty. If first is -1, our queue is empty, right? Because nothing has been populated in our queue. When our queue has an item added to it, first gets updated to be 0, or it becomes 1 or 2. And if it gets dequeued, we will eventually go back to the point that it becomes -1. And then at that point, the queue is empty again. So we can define isEmpty as return first equal to -1. So we have defined clear and isEmpty. Let's now get to the meat of our queue implementation. And the first method would be enqueue. So I'm going to define enqueue. And while we're implementing this method, let's keep the example open on the side. If you remember from our example, the first time when the queue is empty, we are going to update our first and last to 0. And the first element in our array gets set to the element that is passed in. So if, and we've already defined isEmpty, so we can say if isEmpty, then our first equals our last, which equals 0. And storage, the first element in our array, is equal to the element that was passed in. And this is now the first element in our queue. Now, another scenario that we ran into was that when we had all our elements filled in, but remember 6, when we were enqueuing 6, that we reached the end of our array in our queue. So we had to go back to the beginning of our queue. So our queue is not full, and we'll define is full in a second. But our queue is not full, but we're at the end of our array. We would say else if the last is equal to size -1, meaning that we're at the end. Then we'll set our last equal to 0, now at the beginning. And for our storage, we add our element. Otherwise, we work as normal. Our last will get incremented because we're going to have another item added to our last, and we'll put our storage at that spot. So we can say else our storage, we increment our last first. So we add the increment indicator before last instead of afterwards, and set it equal to element. So you may think you're done, but I just said before, we had one more scenario. Our queue is full, right? If we ran this right now, we're not checking if our queue is full. So we'll actually just constantly overwrite our queue. So let's actually make this a method in our class so that we can refer to it outside of just enqueue. This is going to return whether or not our queue is full. Now, we actually defined how we look for our queue being full when we did our example. We said that if our first is equal to 0, or the beginning of our array, and our last is equal to the size of the array minus 1, and in this case it was 4 because the size of our array is 5, or our first is equal to the last plus 1. Because if our first here is equal to last plus 1, we are also full. So first is 1 and last is 0 plus 1. Our queue is full. So we can return first is equal to 0 and last is equal to size minus 1, or first is equal to last plus 1. This is how we check if our queue is full. So before we call any of these scenarios, we want to say if our queue is not full, so not is full, then we're going to proceed with this code. So if our queue is full, let's just outprint something. So we'll say otherwise, cout queue is full. So now we have implemented enqueue. With that, let's implement dequeue. So now let's look at the scenarios that would happen when we implement dequeue. Let's think about the scenario where 1 is the only element in our queue. So in this case, when 1 is the only element in our queue, when we dequeue 1, our queue becomes empty. So how do we know that 1 is the only element in our queue? We can say if our first is equal to our last, then let's make our queue empty. So if you remember, we could call clear, or we could just say first is equal to last, which is equal to -1. This now indicates that our queue is empty. If we called the function is empty, we would get back true because first is equal to -1. Now let's think about another unique scenario when we dequeue. And that is when our first is actually at the end of the array. In this case, since our first is at the end of the array, the next element in the queue is the first element in our array. So we would say else if first is equal to our size minus 1. This means if first is the last element in our array, then make our first equal to 0, which will be the first element in our array, respecting the circular idea of what our queue is. We are making the array work as if it was circular. Otherwise, we have no special scenarios. In that case, if we dequeue in a normal scenario, so let's say here we dequeue 2, the next first will then be updated to 3, the next element in the array. So we just increment. So else first plus plus. So we did all this work, but in our function, we also want to return the element that is being dequeued. So before this work is done, we'll hold a placer dequeued item. This will be a temporary hold for what element we are dequeuing from the list. Then after we update first, we will then return that temporary item. So there, you have now successfully implemented dequeue. The last method that we want to implement is first element, which is going to just return the first element but not dequeue anything. So we're just peeking at what the first element is in our queue. So we kind of already got the answer right here in our dequeue. So let's define our function. So if you look at this, all we would do is return storage first. And this is going to return the first element in our queue, but it's not modifying our queue in any way. So now we have implemented our queue. Let's test our code. So I'm going to make a main function here, and we're going to declare our queue. In this case, we are going to do a queue that just holds integers. Make this really simple. So I'm going to call this queue int queue. And at this moment, if we called is empty, our queue is empty. So we call out cout queue is empty. And line, this would return 1. Then let's add an element to our queue. After adding an element to our queue, if we call is empty, we should get back 0 because our queue is no longer empty. So let's add more elements to our queue. We're going to add all the way up to 6 because in this scenario, since we are not passing in the size of our queue, it's going to default to 5. So once we get to 6, we will get the message in our console that the queue is full. So once we get to 6, we would outprint queue is full. Now let's dequeue. When we dequeue from our queue, what is our first element at this point? Our first element is 1. So our outprint should be 1. After dequeuing, if we went to peek at what our first element is, it should now say 2. Let's now test when we clear our queue. So we can do queue dot clear. If we cleared our queue, we should now, when we call is empty, return back 1. So there you have it. When we run this code, we will outprint 1, then 0, then queue is full, then 1, 2, and 1. So let's compile and test our code. And there you have it. We have 1, then 0, then queue is full, and then 1, 2, 1. So now you've learned how to implement a simple queue in C++. Now, you know how to implement a queue. That doesn't mean that you need to always implement a queue from scratch. Understanding the data structure is what's important. You understand how the data structure works, and now you understand if you implement it using an array, how you're utilizing that array as if it's circular. That is what's important here, understanding those concepts. You take these concepts and you use the standard template library in C++ to solve your problems that are related to queues. So, why do we use queues? Now, queues are frequently used in simulations. And actually, it's been analyzed to the extent that it's actually become this advanced body of work in mathematical theory called queuing theory, which actually happened to be one of my favorite courses when I was in my master's program. I actually just teased and called it statistics with calculus, so you can kind of get the gist of what queuing theory is. But it has been so studied that it has its own spot. Now, outside of the pure mathematics world, queues are really important when we go around with defining ways that our processor power or our memory usage is going to be used. At the root, at that lower level, just like how stacks are being used, queues are also being used to give processing power and memory time in our computers. And also, queues are something that is normal in our day-to-day life, right? You see queues every day. You see queues when people are going to buy something at the coffee shop. You wait in a queue to get your order. And that's how a lot of e-commerce stores work as well. So you have a queue, which is first come, first serve of who gets those items. And after they get those items sell out. So these are things that you would use when you go back and you work in a more non-academic lifestyle and maybe not the crazy pure mathematics world. So queues are important because they replicate real world objects that exist. So there's one more thing that I want to teach you about queues before we end this video, and that is priority queues. So priority queues are an extension of queues. And the reason priority queues exist is because in some circumstances, first in, first out operation of a queue may need to be overridden. It might occur due to priorities that are associated to elements of the queue, and that would end up affecting the order of the processing. So priority queues are when elements are removed based on priority and the position. So the difficulty in implementing priority queues is to accommodate to those priorities while also efficiently dequeuing and enqueuing. Because elements typically arrive randomly, so their order typically respects no special priority. So within a priority queue, every item has a priority associated with it. And an element with that high priority is dequeued before a low priority. And if two elements have the same priority, they're going to be served based on how they were ordered in the queue. So I suggest after learning about our queue implementation to try to take on implementing a priority queue on your own. Now, after you kind of understand how a priority queue works, you can again use the standard template library's priority queue. So now you've learned about queues and you've also learned how to implement a queue. In our next video, we are going to learn about binary trees. So if you liked what you saw, please remember to subscribe to my channel so that you can get notified about other videos that I upload on YouTube. And until then, happy learning.